All right, let's get into climate 101. What do you need to know about the climate as it was in the past and the climate as it is today? So to talk about what's happening with climate and global warming, we really need to understand where the Earth gets its energy from. And there are four big forces at work. There's solar, gravity, radioactive decay, and the rotation of the Earth. Now, solar energy drives many of the surface processes such as wind, currents, the water cycle, and the overall climate system, which is what we want to have a look at today. But things like gravity, that makes rivers and other materials flow downhill, and it creates tides from the moon's gravitational pull, so that's some energy there too. Radioactive decay then creates heat in the Earth's interior, and we get some heat from that too, or some energy from it. And Earth's rotational forces, that influences currents of air and water as well. So all gives energy into the big Earth system. So the majority of our energy and heat does actually come from the sun. It's an absolutely huge ball of nuclear fusion that lies in the heart of our solar system, about 150 million kilometers from Earth. So far away that it takes light 8 minutes to get from the sun, from the outside of the sun, to Earth. But it actually gives us about 173,000 terawatts of energy. That's how much falls on Earth continuously in the form of the Earth's rays. And to put that into perspective, that's more than 10,000 times the world's total energy usage. So it really makes sense that the sun would be a big driver of the Earth's rising or falling temperatures, depending on what it's doing at any particular time. And this is to scale, by the way. This is actually how much energy we use compared to how much solar energy hits the Earth. So over time, the sun is actually getting a little bit hotter. But we're talking over an awfully long time. It's about 5 billion years old, and it'll last for about another 5 billion years. So it's been around. So seeing any major change in the Earth's climate through changes in the sun, it wouldn't really happen. It happens on such a long time scale. We don't see those patterns over a few hundred years. The sun actually does go through cycles, though. Every 11 years, the sun has, which has a huge magnetic field, that goes through a field reversal. So just like you would see in something like a north and south pole of a magnet, the sun has the same thing, and it flips. And it causes the change in output. It can change anything to about 0.15%. So again, would that have an effect on Earth? Well, possibly, but could it cause climate change? Probably not. I mean, the changes we're talking about are really, really small. The changes in the time in which they take place just aren't enough to cause the extent of the warming that we're seeing in our climate today. And there are other factors at play here as well, though. The Earth goes through a few longer cycles that definitely do have an impact on how much energy falls on the Earth from the sun. So one of them is orbit. And the Earth's orbit isn't really round. It's more like an egg or an ellipse shape, just like all orbits in the whole solar system and everywhere in the universe. But so naturally, that means that at some points we'll be a little bit closer to the sun, and at some points we'll be a little bit further away as well. Describe it as an egg, though. I mean, it's exaggerated here for you guys to see, but it's almost a perfect circle. The changes aren't really that much. It goes from being almost a circle to a little more like an egg shape over the course of 100,000 years, so over a long time. Currently, our eccentricity, which is how much that changes from the circular shape to the egg shape, is almost a perfect circle. We do still get a little bit close to the sun, but that's in January, and a little bit further away in June. So that's our closest approach in January. Our furthest away is in June. But these small variations, again, over that time scale, it just isn't enough to cause the warming that we're seeing. Another variation, though, is the tilt of the Earth towards the sun. So over a 40,000 year cycle, the Earth changes its tilt. You might have seen a globe where the Earth doesn't point straight up, and that's because the Earth is tilted over around 23.4 degrees. And that's close to the middle of the range of what the tilt can do. It goes more tilted and less tilted over time. And where we are at 23.4 is around about in the middle. And what that means for the climate is that the more tilted over we are, the more extreme our seasons will be. It's because when we're tilted over, the more solar radiation will fall on Earth in the summer and even less than normal in the winter. But like I said, we're at the midway point of a 40,000 year cycle. So it's not going to have affected the climate that much over the last few hundred years. Okay, the last of these cycles, and these are all called Milankovitch cycles, by the way, a staple of physics. The last of the cycles is down to the Earth's wobble. So the Earth doesn't spin like it does on a globe, perfectly steady. It actually, if you try spinning an egg or maybe a spinning top, you'll see what I mean by the wobble. It kind of wobbles around as it starts to fall over. And this also has an effect on how different parts of the world experience their seasons. But this is a cycle of around 25,000 years. And what's interesting is that the opposite is also happening, which is really weird. Climate change is also having an impact on the wobble of the Earth because of the way the weight is shifting around the Earth. Some parts are finding they're having droughts more. Some are getting kind of mass ice shifts where it melts and flows away. So the wobble of the Earth can cause different amounts of heat to land on the Earth. But also climate change and the changing climate is changing the wobble, which is super strange and a little bit weird. So those are some of the more mechanical processes that affect the Earth's climate, but there are loads more. And there are a number of changes that can cascade down to make a noticeable shift in our climate. And one of the largest is how we retain that heat that arrives here from the sun. So all those processes affect how much heat arrives here, and then it's what we do with it then that's starting to really change. So we receive, store, or sometimes reflect the sun's radiation in a bunch of different ways. Some never gets through our atmosphere. It kind of just stays out there in space. Some is absorbed by our oceans. Some is taken in by plants, and sometimes is stored deep within the earth. And some is just reflected straight back into space. It hits the earth, maybe hits something white or bright like an ice cap, and just gets reflected back out. And all these different processes, they make up that cycle of how much energy do we get coming to earth and how much we keep. And how much energy is coming to earth, well, that's been the same for a little while now. A long time when we're talking about human lifetimes and human life scales. How much we keep here on earth, that's what's changing. The climate here on Earth is taken as the temperature, humidity, atmospheric pressure, wind, rainfall, and other meteorological elements on an area of the Earth's surface over a long time. In simple terms, climate is the average condition for about 30 years over a large portion of the globe. So it makes sense that changes we've been making to our planet will affect the Earth in some way. And it turns out it's been making it hotter by altering the greenhouse gases in the atmosphere. That in turn has other effects, and we've started changing the planet faster than it otherwise would be in a natural climate cycle. And it's true that Earth has been hotter in the past. However, at some points there've been little to no ice on the planet at all. It's like a greenhouse Earth or a tropical Earth where there's tropical forests everywhere and everywhere you look. So there's been kind of very little to no ice at points in the past, but there's also been points where we've had the whole planet maybe been covered in ice, call it snowball Earth. So it goes to these natural climate cycles. So, it's also true that there's been more carbon dioxide in the atmosphere in the past as well, and less. So these cycles do occur. But at all of these times, life just generally would have found it really, really hard, if not maybe impossible to survive. And in none of these times did humans walk the planet. Like at the times where there was no ice on the surface of the Earth, or there was ice all over the Earth, and we weren't around at the last time that there were carbon levels this high, we weren't around to see it. So whilst the Earth does go through some natural climate cycles, we now, with all these cycles being at about a medium, about an average, we've hijacked this current cycle, and they're changing it in ways that are totally predictable. We kind of predicted this because you dig up fuel from the ground and you burn it, then we can predict what's going to happen. So that's all down to then the carbon cycle, which we're definitely going to cover in a little bit.